Sixth grade, welcome to Friday, your final math lesson of the week. We're going to cruise through lesson 30 today, and we'll see how where we started this week with finding common multiples are going to help us today as we have to add fractions that have uncommon denominators. Let's see how you did on your power up. Back to letter F. Segment, ray, line, acute angle, right angle, obtuse angle, triangle, quadrilateral, pentagon, hexagon, octagon, and a regular polygon. Hopefully you got those things down pretty good. The mental math section would read like this. Letter A, I added, I got $3.98. B, I multiplied by 1,000. Slide that decimal right 3 times, $150. 4 times 3 gave me 12, so 3 times 3 is 9, 9 twelfths. D, multiplied 420. F, added together, I got 3 4/3. 4/3 simplifies to 1 1/3. Added to the 3, I have 4 1/3. Divide by my denominator 5 times my numerator 3 is 15. Estimate the sum. 43 becomes 40, 23 becomes 20. Sum means add. 40 plus 20 is 60. Half of 88 is 44. Plus 4 is 48. Divide by 8 is 6. Times 5 is 30. Minus 5 is 25. Double that to 50. Minus 2 is 48. Divide by 2 is 24. Divide by 2 is 12. Divide by 2 again is 6. It says, artists since the 16th century have used a geometric illusion in painting and drawing called one-point perspective. One-point perspective allows the artist to make it appear that objects in the drawing vanish into the distance, even though the drawing is two-dimensional. Follow the 5 steps provided to create a one-point perspective drawing. And guys, I just tell you to do that. Draw your horizontal line, which is your horizon. Put your vanishing point on it. The construction shows the top of the buildings. The next step, I think, is what's important, guys. It says the edges of the building sides need to be both perpendicular, but then they also need to be parallel. So I need to go straight across, horizontal from those things. Don't keep going at an angle on your construction lines. Then it says all receding lines will merge at the vanishing point. Erase the construction lines and add details to complete the one-point perspective drawing. So they try to show you those dotted lines and that need to get erased, and you could put hey, these are buildings in a road down the middle, and then some people put little dash lines for the dash marks in a road, and add some windows and some doors on those vanishing lines, all things like that. That can go to that vanishing point using simply a straight edge, whether it's a ruler or the edge of the book or something to do that. We'll have to get that as the extra credit art assignment coming up, to do a one-point perspective drawing. I didn't do it on the board, guys. You can practice it down on the bottom yourself following those steps. Okay. Yesterday we rounded numbers. Today we're going to work on what I already hinted at, looking for common denominators and then using common denominators to do adding, subtracting, comparing, and things like this. And we'll work from the simple ones to some very difficult ones today. At the top of the page it says this: if two fractions have the same denominator, we say they have common denominators. So 3/8 and 6/8 have common denominators. 3/8 and 3/4 do not have common denominators. If two fractions do not have common denominators, then one or both fractions can be renamed so that both fractions have common denominators. We remember that we can rename a fraction by multiplying a fraction that is equal to 1. So we can multiply by 2 over 2 to rename 3/4 so that it has a denominator of 8. So 3/4 times 2 over 2 becomes 6/8. Example 1 is the start what we have to do today. Rename 2/3 and 1/4 so they have common denominators. So, guys, I'm over here with 2/3 and 1/4, and I got to figure out how to have common denominators. One quick way to do that, guys, is multiply the fractions by the other's denominator. That will always give you a common denominator. It just might not give you the lowest common denominator. So when I took 2/3, all I did was multiply it by 4 over 4, this denominator. I'm going to take this one and multiply it by the other, 3 over 3. Multiply the tops, 8. Multiply the bottoms, 12. Sorry, my 8's so sloppy. Multiply the tops, 3. Multiply the bottoms, 12. I now have common denominators. Remember, we need common denominators to add and subtract. Don't ever just do 2 plus 1 is 3 and 3 plus 4 is 7. This equals 3/7. No, it does not. This equals 11/12. Okay, so you have to have common denominators to do that. This way not only gave me the least common denominator, but it also was very, very fast. Okay, now we're going to say that they're rarely going to do those problems for you guys. That's not enough. So example 2 says, write these fractions with common denominators, then compare the fractions. So once again, I'm just going to multiply by the opposite one. I'm going to take 6 times 9 over 9. 9 times 5 is 45. 9 times 6 is 54. I'm going to take this one times 6 over 6. 7 times 6 is 42. 9 times 6 is 54. Now I can compare. 45 is bigger than 42, so 5 6 is greater than 7 9ths. Now, guys, the reason they gave you that problem is some of us would say, well, 5 is less than a 7 or 6 is less than a 9. It has nothing to do with it. You have to have common denominators, and it was a real quick way to just do that. Now, some of you might be saying, Mr. Bauer, you could have switched those to 18s. I absolutely could have. Then you just have to think, how did I get from 18 here times 3? How did I get from 18 here times 2? Still, the comparison would be the exact same result. It would just be with different fractions that would be equal to each other. So my way is just the fastest way I can find common denominators when it's problems like this. It doesn't matter what my denominators are as long as I can to work with them. When I add and subtract, I might want to do better common denominators. So example 3 says, arrange these following fractions order from least to greatest. Hint, you may write the fractions with common denominators to help you order them. So now I'm supposed to write these in order, guys, and I want to find common denominators. So I look at 3, 6, and 12, and this is why we had that least common multiple lesson in 27. So I can say, hey, what's the common multiple between those? Now, guys, 12 is the common multiple in all of these. Now I got to ask myself, how did I get there? Well, I multiplied this one by 4 over 4. I multiplied this one by 2 over 2. I multiplied by this one by 1 over 1. That one stays the same. This one times the top gives me 10 twelfths. This one times the 12 gives me 8 twelfths. Now I can compare. What's the smallest one? 7 twelfths. What's the next one? 8 twelfths. What do I write down? 2/3. What's the biggest one? 10 twelfths. What do I write down? The fraction they gave me. 5 6. And I was able to put those things in order. Okay, here's where they'll pound it into your head. To add and subtract two fractions that do not have common denominators, we first rename one or both fractions so they have common denominators. Then you can add or subtract. Common denominators first, then add or subtract. So the first one says 3/4 plus 3/8. Now guys, we have to only rename one of them because the common denominator is 8, so this one stays the same. This one I have to multiply by 2 over 2 to get 6/8. Now I have common denominators. Now I add the tops, 9, bottoms stay the same, simplifies to 1 1/8. So I only had to rename one of those. Example number 5, now I'm subtracting. I have 5 6 minus 3/4. Okay, I'm going to show you two ways to do this one. The one that is the lowest denominator would say they equal to 12. So this is times 2 over 2, this is times 3 over 3. That gives me 10 twelfths, that gives me 9 twelfths, I subtract and I get 1/12. Okay, the second way to do it is like what we did over here. I could just multiply by the other's denominator. So I took this and I multiplied it by this. So if I took 5 6 times 4 over 4 gives me 20 over 24. I take this one times this and I have 3/4 times 6 over 6. That gives me 18 over 24. I subtract. 20 minus 18 is 2 over 24, which reduces to 1/12. Same exact answer. What I have to do here, I had to reduce when I was done. I didn't have to reduce here, so that was nice to not have to reduce. But the reason I might do this sometimes, guys, is if I can't think of the common denominators quickly in my head, simply multiply by the other one and get to work on it, okay? So too often we sit there and we stare at the problems and say, I don't know what the common denominator is, what should I multiply by the other denominator and get to work. Okay, number 6, takes it one step farther with mixed numbers now. So I'm subtracting those. Common denominators would be 6, so this one would be times 2 over 2, gives me 8 and 4 6, minus 5 and 1 6. Multiply the tops, 3, bottoms stay the same, subtract the whole numbers, 3. And now I have to reduce, guys, to 3 1/2. So you might still have to reduce even though you had the lowest denominator as you could get there. They lots of times will give you problems that make you have to reduce that down a little bit to be able to solve those problems. 7, I'm adding. This time I have 3 numbers. I have 2, 3, and 4. I'm starting to think what number goes into both 2, 3, and 4. 12 goes in there. So I got to make them all equal to 12. And we've been doing this for a while, guys, thinking, how did I get there? Multiply by 6 on the bottom, multiply by 6 on the top, multiply by 4 on the bottom, 4 on the top, 3 on the bottom, 3 on the top, multiply 6, multiply 8, multiply 9, add 14, 23. So I have 23 twelfths. Divide goes in there 1 time. Subtract is 11 twelfths. I can't reduce that. 1 and 11 twelfths. So with addition, guys, they can give you more than 2 numbers. Subtraction only going to be 2 and 2, but with addition, they can give you 3 sometimes. And last but not least, it says, recall from lesson 27 that prime factorizations helps us find the least common multiple. We factor the numbers, then we find the pool of numbers from which we can form either number. Consider 24 and 32. 24 is 2 times 2 times 2 times 3. 32 is 2 times 2 times 2 times 2 times 2. We can form either number from a pool of the factors containing the 5 2's and the 1 3. Thus, the least common multiple between 24 and 32 is 96. Okay, use the prime factorization now to help you add those numbers. So guys, they already did all that math for us. They broke the whole thing down. I had down here on the board to show you how I broke it down where they gave you that list. But they said, hey, the least common multiple is 96. Well, that's awesome. I now know I'm going to 96. That might still be a challenge for me, guys, if I can't look and see how I got there. Now, step 1, they're saying, use that shortcut to see that 96 is your answer. How did I do that? I took the ones that had the most 2. There were 5 here, and there was this 1, 3 here. Okay, now, guys, this number had 5 2's. This one had 3 2's. So if I cross out 3, I cross out 3. What am I left with? I'm left with 2 times 2 is 4. So how did I get to there? I multiplied by 4. What am I left with here? The 3. So I multiplied this one by the 3 to get there. Then I multiply the top, 15, multiply the top, 28, and in this case we are adding those problems together. So 15 plus 28 is 4396. And that challenge problem is just awesome because you got a big, huge factor with a huge numerator and a huge denominator. And every once in a while, they'll give us those that are hard for us to see the common denominators. Most of your problems, guys, are going to be in this range where you have numbers that are a little bit easier to find and add and subtract together. Stressing today, make sure you have common denominators. Do not just add the numerators and the denominators together. You can never do that. The denominator has to be the same and stays the same. All right, we're ready for a little math problems. So right here we go. Number 1, 5 stars of the basketball team were that many inches tall. What was their average height? Find average. I'm going to add 76, 77, 77, 78, and 82 all together. So I got a 10 here, 17, 24, 30. 4 times 7 is 28. 28 plus 8 is 36, 37, 38, 39. I'm taking my 390, I'm dividing it by the 5 players. Goes in there 7 times is 35, 40, gives me 8. The average height was 78 inches. Smallest is 76, biggest is 82. Your answer needs to be in between those two guys to make sure you do your checking. 78 inches. Number 2, Mary bought 6 pounds of carrots for 87 cents a pound and paid for them with a $10 bill. How much did she get back in change? Step 1, 87 times the 6 pounds gives me a 42. 56 is 60. Subtract from my $10. Wait, what did I just write over here? 10 times 607. 57 times 6. Okay, so hang on. I did 42. I did 7 times 8. I do 6 times 8 is 48 plus 4. This is where I went wrong. Sorry about that. That's 48. Now I'm ready. 52. I don't know what I was doing over here. Confused myself there. Now we're back. So now I have $5.22. Sorry about that, 6th grade. Okay, cross that out, becomes a 9, 10, 9, boom. 10 minus 2 is 8. 9 minus 2 is 7. Decimal point straight down. 9 minus 5 is 4. $4.78. So I had done 7 times 8 is 56 instead of 6 times 8 is 48. Number 4, 140 of the 260 students in the auditorium were not 7th graders. What fraction of the students in the auditorium were 7th graders? So step 1, I have to do 140 of the 260. So I'm going to reduce that down by chopping off a 0. I'm going to divide by 2, gives me a divide by 2 over 2, gives me a 7 and a 13. Now that tells me how many were not 7th graders. I want to know how many were 7th graders. I subtract. 13 minus 7 is the 6. 13 stays the same. So 6/13 were. Number 5. In the following statement, change the percent to reduce fraction and answer question. The Dalton completed 30% of their 2,140-mile trip the first day. How many trials did they do the first day? So I have 30%. Percent means out of 100, chop a 0. So now I take my 2,140, I divide it by 10, and then multiply it by 3. So dividing by 10 chops the zeros. 214 times 3. I'm not going to try to write that side by side. That's not how I do multiplication. So I write it up and down. 12, carry the 1. 3 plus 1 is 4. 3 times 2 is 6. So they went 642 miles. Question 2 says how many miles of their trip do they still have to travel? So I'm going to take 2140 and subtract 642 from it. 10 minus 2 is 8. 13 minus 4 is 9. 10 minus 6 is 4. And 1 minus nothing is 1. They still have 1,498 miles to go. Number 6, if the perimeter of a square is 5 feet, how many inches long is each side? So perimeter is 5 feet. Step 1, switch to inches. 5 times 12 is 60. Step 2, it's a square, so I divide by 4. And I get an answer of 15 inches. Turning the page in my math book, number 7. Use prime factorization to subtract these fractions. Okay, guys, so this is something where I'm looking at 1/18 minus 1/30 and saying I don't know what the common denominator is. So I take 18, I divide it by 2 and 9 and 3 and 3. I take 30 and I chop it into 3 and 10. I take 10 and chop it into 2 and 5. Okay, so now I start looking, guys, and I see this. I see that there's 1, 2 here and 1, 2 here, so I need to use the 1, 2. It doesn't matter which one I pick. I see that there's 1, 3 here, but there's 2 3s here, so I'm going to use the 2 3s because there's more. I see that there's 1 5 here, so I have to use that as well. So 5 times 5 is 10. 3 times 3 is 9. 9 times 10 is 90. So that's how I found common denominators. Now the other thing you can do is you can cross out what you use. So I cross out this 2 here, I cross out this 2 here. I cross out this 3 here, I cross out the 3 here. So from this one I have to take this guy times the 3 that's left, and from this guy I take this one times the 5 that's left. 1 times 5 is 5, 1 times 3 is 3. I subtract, I get 2, the 90 stay the same. Divide both by 2 is 1/45. Okay, I want you to think of everything we did here, guys. They write you a little problem that says, please subtract those 2 fractions, and we have to do a ton of work to try to get there. Number 10, write 32% as a reduced fraction. 32% out of 100. Always look for the 4s with that one. Gives me 825. B, use prime factorization to reduce 4872. Now 6, I would not do prime factorization with this one because I can look at this one and say let's divide by 8. So if you can look and see a start, get started on it. Dividing by 8 gives me 6. Divide by 8 gives me 9. Now I can go again and divide by 3, which would give me 2 and 3. I think that's faster than listing the prime factors of everything and then crossing numbers out. So remember, their goal is can you reduce? It took me 2 steps to get there. I think those 2 steps went faster than trying to write the prime factorization. That's what you need to decide as you do those. Okay, 12A says, what is the area of the smaller square? The smaller square is made by a 3 by 3. So this guy's 3 by 3 attached to a 4 by 4. 3 times 3 is 9. We are messing with inches, so it's 9 inches squared. The next one is, what's the bigger one? This one's 4 times 4. That would be 16 inches squared. C says, what's the total area? Add those together, 25 inches squared. So 6, they gave you step 1, step 2, because soon we're going to get finding what we call complex areas. I have my L shape. Can I figure out the area of it? One way to do it is to break it into 2 pieces and add them together. Yesterday you learned take it as a whole and subtract this missing piece out. So they're teaching you those ways without actually having the lesson yet. Number 13, what is the perimeter of a hexagon that is formed by joining the 2 squares? So we're back to this problem, guys. And we had it chopped here, and this was 3, 3, 3. This was 4, 4, 4, and I am missing this guy right here. This side is 4, this side is 3. I'm missing this 1 right there, okay? So I do 3 plus 4 is 7, and 11, and 15, and 16, and 19, and 22. So 13A is 22 inches. 13B says the perimeter of the hexagon is how many inches less than the combined perimeter of the 2 squares. So guys, now they want, what's the perimeter of this square? Well, that's 3 times 4 is 12. What's the perimeter of this square? It doesn't look like a square. Sorry, it should look like a square. That's 4 times 4 is 16. Add them together is 28. They said is how much less, so I take my answer for A and subtract it from the real thing. 28 minus 22 is 6. So A is that, B is 6 inches. C says explain your answer to B. I subtracted. I mean, they're just saying, can you explain your thinking that you did right there? We did. Number 14, write the prime factorization of 5,184 using exponents. Use your answer in A to find what is the square root of 5,184. Man, what a problem. Okay, so I have 5,184. Now, guys, I have no idea what the square root of 5,184 is. So I'm just going to start to break this thing down. And I'm going to do it by this. I could divide by 2 because they're both even, but I like to try to get something that's a little bit bigger. So I did 5 plus 1 is 6, plus 8 is 14, plus 4 is 18. So I know it's divisible by 9. Now I actually have to divide by 9. 9 goes into 51. 5 times, I'll just write it out here so you can see what I'm doing. That goes in there 5 times, that's 45, that's 68. It goes in there 7 times, that's 63. That subtracts, that gives me 54. It goes in there 6 times. So now I have a 576. Okay, I divide that, that's 3 by 3. I look at this one, guys. This one's still divided by 9 right here. So I'm going to hit this by 9 again. 576 divided by 9 goes in there 6 times. That's 54. That's 3. That's a 6. Goes in there 4 times. I have a 64. Okay, that also is 3 by 3. Now I have a 64. That's 8 by 8. And we've done 8 so many times, guys. I hope you know it's 2 times 2 times 2 times 2 times 2. Boom. I have them all. Okay, so now to A, it says write the prime factorization using exponents. So I have 1, 2, 3, 4, 5, 6. I have 2 to the 6. I have 1, 2, 3, 4 3s times 3 to the 4th. I got A done. That's my answer for A. B says find the answer. What's the square root of that? Now remember, guys, I got to chop these in half. So this is 2 to the 3rd times 3 to the half. So the exponents get chopped in half. Well, 3 times 2 is 9, and 2 times 3 is 8, and 9 times 8 equals 72. So my answer for B is 72. So 72 times 72 gives me 5,184. So answer for A here, answer for B, the 72. What an awesome problem. Turning your answer key over, we're at number 16. List the single-digit divisors of 5,670. Wow, it's been a while since we've done one of these. I'm going to add the numbers together. That equals 18. All right, here I go. 1 goes into it because 1 goes into everything. 2 goes into it because it's an even number. 3 goes into it because 3 goes into 18. 4 does not go into it. I divide by the last 2. 4 does not go into 70, so 4 doesn't go into it. 5 goes into it because it ends in 0. 6 goes into it because of the 2 and the 3. 7, I need to check. The only way to do that, guys, is to do the actual math. Now, maybe you saw right from the start, 7 goes into 56, 8, 7 goes into 7, 1, 7 goes into 0, 0, so 7 goes into it. To check 8, I do the last 3. So I'm doing 670. Divided by 8 is 8. That gives me 64. That gives me a 30. 8 doesn't go into 30, so 8's out. 9 goes into it because of this 18. So, whoo, it's been a while, guys. 1, 2, 3, 5, 6, 7, and 9. Number 21. Starting to work from some of today's lesson. I have 1/2 plus 1/3. Need common denominators. So I'm going to take this one times 3 over 3. I'm going to take this one times 2 over 2. That gives me 3, 6. That gives me 2, 6. I add them together and I get 5, 6. 24. This time we got a big multiplication problem. I have 4/5 times 5/3. I made it improper in my head. Times 9/8. So multiply the whole numbers, add the denominators. Now I start to look for things I can cancel. 5s are gone. 3 goes into 9 3 times. 4 goes into 4 once. 4 goes into 8 twice. I multiply the tops. I get 3. I multiply the bottoms. I get 2. That simplifies to 1 1/2. 27. Now it says this for the directions. For each exercise, record an estimated answer and an exact answer. So don't miss your directions, guys. Step 1, I'm going to round. That becomes 4. That becomes 2. I add them together. My estimated answer is 6. Now I have to do the exact answer. Common denominators are 6s, so I have 3 and 4 6 plus 1 and 5 6. Add together gives me 9 6, gives me 4. That equals 5 and 3 6, which equals 5 and 1/2. Actual, estimated. Great problem. 28's making me do the exact same thing, but this time with subtraction. I have 5 and 1/8 minus 1 and 3/4. 5 and 1/8 rounds to 5. 1 and 3/4 rounds to 2. I think my answer should be somewhere near 3. Actuals times 2 over 2. This gives me 1 and 6/8. This one stays the same. Now, I can't do the subtraction, so I make that a 4. I'm bringing over an 8/8, and I'm adding it together to give me 9/8. 9 minus 6 is 3. The 8 stay the same. 4 minus 1 is 3, and I have an answer of 3 and 3/8, which is pretty close to